We started today with a diagram of when you toss 3 coins. So remember, your first coin was heads or tails, your second coin is heads or tails for each of those 4 outcomes, and your for each of those 2 outcomes, and your third coin, you need 2 more branches from each of those 4 outcomes for heads and tails, and then you have 8 outcomes at the end. And this was just again practice at figuring out the probability of whether or not a game is fair. We went over your quizzes, and remember, if you got less than 14 correct, you need to do your corrections over the weekend, and you need to show up Monday at lunch or Monday after school to do that retake. And then we got started today on, first of all, looking at complementary events. So from our last lesson, if 5/9 of the students played basketball or soccer, the complement to that is what fraction of the students do not play basketball or soccer. So either you play it or you don't. And you guys knew right away it was 4/9, and the way you get that is you have to think, gee, you either play it or you don't. So everyone is 9/9. It's the entire group, so we just subtract 9/9, 5/9 from 9/9, and we get 4/9. So really all I have to do is think about what plus 5 will give me 9, and it's 4/9. And then last time in class we had the probability of a student's name being drawn at random from the entire middle school that was in band or choir was 7 out of 38. So the fraction of the students not in band and choir would be the difference of 7/38 and 38/38, which is 31/38. So complementary events are just events that add to the whole number 1. So if the probability is the event is the probability of something happening, the complement is it not happening. And that's the easy way to remember. What is the meaning of complement? It's the probability of something not happening. So in this case, the probability of a die, just if I roll a die, landing on a number less than 3 is 2 out of 6 because there are 2 outcomes, this one and this one. It can land on a 1, that's less than 3. It can land on a 2, that's less than 3. That's 2 outcomes that are favorable out of 6 outcomes. And 2 6 simplifies to a third. So the probability of a die landing on a number less than 3 is a third. The complement is the probability of it not landing on a number less than 3. So if the probability of it doing that is 1/3, the probability of it not doing it is 2/3, because 2/3 and 1/3 is 3/3, and that's the entire possible outcomes. So there's a formula in your book, but it's really best just to remember the meaning, and then you don't need to memorize a formula. So the probability and its complement always add to one whole. So if the probability of an event is a fraction, the complement of it means the probability of the event not happening. Oh no. Just to remind you now, last lesson we did mutually exclusive events, and an example of that was when a student could be in band or choir, but not both. So remember, in a Venn diagram, there'd be 2 separate circles called disjoint. So a mutually exclusive event is when you can be in one or the other, but not both. And you guys found the probability of that happening last class. So today what we're dealing with is, how do you find the probability of one or the other happening when they do have an overlap? And I want you to think back when we studied Venn diagrams and we had this overlap. To find the number of people in event A that were not in the overlap, we had to subtract the overlap from A. And we had to subtract the overlap from B to get what was outside of the overlap. Well, finding the probabilities is very similar. So I said, what happens when a person can be in both band and choir? How do you find the probability of a student being chosen at random now? Well, go back to what we did with Venn diagrams. If there are 6 students who are in both and 23 are in band, 23 minus 6 gives us 17 in band that are not in choir. And the 12 in choir minus the overlap, 6, gives us 6 in choir who are not in band. If I wanted to know the total of these students now, I add 17 plus 6, which is 23, plus 6 is 29. So I have 29 students that are either in band or choir. So if I want to find the probability of a student being chosen at random when there are students in both, it's very similar. You do what you did before, 23 plus 12 out of 190, that was 35, and now we subtract the overlap. And 35 minus 6 is 29 out of 190. And notice that 29 is the same number that we got when we added all 3 of these. We got 29. So literally, it's the same process, only it's even easier. I add the probabilities and I subtract the overlap just once. And that's how I get 29 out of 190. And that is in lowest terms. You always simplify. Okay, different problem. We did this one last time when they were mutually exclusive events, but now I'm going to tell you that soccer and basketball are offered in different sports seasons, so 32 students actually play both sports because now you can. So if a student is chosen at random, what's the probability the student is either on the basketball team or the soccer team, but not both? So just like last time, we added the 45 180ths to the 55 180ths, and we got 100 180ths. Now, since we have 32 students who play both, we must subtract that overlap because we counted those 32 in each of these numbers, and we only want to count it once. So we subtract the 32 out of 180, and we get 68 180ths, which simplifies to 17/45. You can divide them both by 4. 68 divided by 4 is 17, 180 divided by 4 is 45. So that's how you deal with events that have an overlap. Okay, here was a new one that you do with your table group. If I toss a pair of fair dice once, what's the probability they'll show a sum of less than 6 or be doubles but not both? And so my first question to you today was, how can you possibly find all the possible sums, which are outcomes in this case, when you roll a pair of dice? And it took you guys a while to figure it out, but you finally came to the conclusion that you make a table. So you make a table like this, and I had a purple die and a green die, or a blue die, depending on which class you were in, and just 2 different dice. And we made a table, and you filled in all the sums. And after you do the addition, it looks like this. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So there are 36 outcomes, because for each one of these 6 outcomes, I have 6 possible outcomes on the other die, and 6 times 6 is 36 possible outcomes. So the first question was, what's the probability of a sum less than 6? Well, circle them all in one color, and there are 10 out of 36 that are less than 6. Here's my dividing line. These are all 6 or bigger, and those are less than 6. Then the second question was, what's the probability of having doubles? Well, all of these sums in green came from adding doubles. 6 and 6 gave us 12. 5 and 5 gave us 10. 4 and 4. 3 and 3. 2 and 2. 1 and 1. And notice I'm circling them in a different color, because in the end I have to subtract the overlap. So the probability of getting doubles is 6 out of 36. And notice that I have 2 outcomes. A 1 and a 1 gives me 2. So that's the outcome that's the sum when I add a double, and it's less than 6. And 2 and 2 is 4. That's a double and a sum of less than 6. This is a double, but 6 is not less than 6. It's equal to 6. So I only have 2 outcomes that belong to both the red and the green. So I have to subtract those 2 outcomes. So 16 minus 2 is 14 outcomes out of 36, and you should simplify it, and that is 7/18. So 2 outcomes belong to both sets, so we have to subtract that from our 16 and simplify, and that's 7/18. And that's the answer to the question. So notice the process. You take the number that are less than 6, the number of doubles, you add them, and you subtract the overlap. And that's how we got that answer. It's that easy. Okay, new one with your table group. I showed you a deck of cards. There are 4 suits in a deck of cards. Jacks, queens, and kings are face cards. They literally have a face on them. And the question was, if I draw a card from a deck of 52 playing cards, what's the probability that the card will be red or a face card, but not both? Yeah, they can't be both. Well, half of the cards in a deck are red. That's 26 out of 52. And there are 3 jacks, queens, and kings in each suit, and that makes 12 face cards out of the entire deck. And 26 plus 12 is 38 out of 52. But we have some that belong to both groups, so you have to subtract the both. 6 of the cards belong to both, and I'll show you those 6. These 3 cards, Jack, Queen, King of Hearts, are both red and face cards. And these 3 of diamonds, Jack, Queen, King of Diamonds, are red and face cards, which makes a total of 6 cards that are in both sets. So you have to add and subtract 6, and we get 32 out of 52. You can divide both of these by 4, and it takes you straight to 8/13. Or you can simplify it in 2 steps. They're both even, divide by 2, both even, divide by 2. Either way, in lowest terms, the answer to the question is 8/13. And then I said, what's the complement of that? Well, the complement of that would be 5/13. You just subtract it from 13/13. Okay, then got through numbers at least 2 through 5 in one class and finished the rest of this for homework. And remember that if you need to do your retake, if you got less than 14 right, you must retake it. That's on the slate for Monday at lunch or Monday after school. And that's it. Have a great weekend.